class. You are welcome to physics class online. Today we'll be looking at another topic which I title Fundamentals of Motion. Fundamentals of Motion. So let's continue. But please make sure you like this video. Make sure you subscribe to this channel. If you have not subscribed to this channel before, please subscribe. Then like this video. And at the same time, make sure you turn on the notification bell as we proceed. Thank you very much. All right, concept of motion. Many scientists have studied motion and its properties because of its importance to life. Motion is very important to life. Every object moves. As we are growing from the womb, if you give birth to a child and the child does not walk, it becomes a problem. So motion is very important to life. If nobody can move and we stay at the point, we won't enjoy life. So motion is very important. The Italian Galileo Galilei, who lived from 1564 to 1642, did the first systematic study of motion. The science of the study of motion done by Galileo is known as kinematics. He did kinematics. Although as we progress in this class, I will explain what kinematic is. Then Isaac Newton was another scientist who did details work on the study of motion. He worked on the aspect of dynamics. All right, let's proceed. This is Galileo Galilei, and this is Isaac Newton. Let's move to class. Now, motion involves a change in position of a body with time. When a body changes in position with time, then that is what motion is all about. It also involves how things move and what makes them to move. It involves how things move and what makes them to move. Because it is believed that objects will not just move if force is not responsible. All right. Now, there are two branches of motion. We have the kinematics and then we have the dynamics. Now, what's the kinematics? Kinematics is the description of how object moves without regard to the force causing their motion. This is when we study motion of a body without regard to the force responsible. However, force are responsible for the movement or motion of any bodies. Now, then the second part is the dynamics. And what is the dynamics? Dynamics is the study of motion with consideration to the force applicable or responsible for that motion. That is, dynamics deals with any object that moves as it do and the forces responsible for that motion. There are types of motion. There are four basic types of motion. They are as follows. Number one, we have translational motion. We have random motion. That's number two. Then we have the oscillatory motion. And then we have vibratory motion. And then we have random motion. Now let's look into details as we move. Number one, we have translatory motion. When a body moves from a point A along a line AB to another point B, we say the body is translated from A to B. And motion performed by a body that is translated from one point to another is called translational motion. So translational motion is the motion of an object from one point to another. For examples, an aeroplane that is flying from Abuja to Lagos, or a car traveling from Lagos to Enugu. The motion of the car or the plane is translational. If I throw a small object up, it goes up, it comes down. The motion of that object is also called translational. Now, translational, they are of two types. Translational could be rectilinear and translation could be curvilinear. Rectilinear means it could be along a straight path, and curvilinear means it could be along a curved path. All right, number two, we have oscillatory, periodic, or vibratory motion. The oscillatory motion is also called the periodic motion. It's also called the vibratory motion. Now, in this type of motion, the body moves to and fro about a fixed point. So the to and fro motion is repeated at successive equal interval of time. Examples are vibration of a guitar string. When you hold the guitar and you pluck the string of the guitar, you discover that it vibrates, it goes up and down, and it is repeated. So any motion of object in that form is called a vibratory, periodic, or oscillatory motion. Another example is motion of a simple pendulum. If I swing a simple pendulum, it swings to and fro, back and forth. The vibration of the molecules of a solid is also what we call the vibratory periodic oscillatory motion. Number three, we look at random motion. In this type of motion, the body moves in a zigzag, haphazard, disorderly direction continuously so that they do not trace definite paths. This object moves randomly. They move in a zigzag without direction and no orientation. This type of motion is exhibited by molecules of gases. Other examples of random motion is the Brownian motion. When an object moves or particles of various kinds suspended in water or smoke particles suspended in water, that's an example of random motion. When the players are playing football on the field, the motion of the ball on the field is an example of random motion because the ball moves at any point. There is no definite direction for the ball as the player passes the ball around. So it is called a random motion. The number 4, we have rotational motion. This is the motion of the body which travels in a circle or ellipse and rotates about an axis. Something very important here is that the rotational motion is always a motion in a circular path but around an axis of rotation. That is the point of rotation. Examples is the rotation of the heart about its axis. Remember, heart rotates but about its axis. And number 2, rotation of the blade of the fan about its axis. When you see the blade of the fan rotating, it's rotated about the rod about the axis of rotation. Then we have number 3, the rotation of a tap about the central axis. See, if you want to open the tap, you rotate it but about a central point. So that's an example of rotational motion. So let's look at this example in the diagram. Say this vibratory body where this press the switch, it vibrates up and down. Linear motion, that's translational. When you push an object, it moves in the path. Then we have the curve. It's also a line movement, but in a curved path. Then we have the oscillatory. You see the motion of the pendulum. That's what we call the pendulum bob. The object moves from A to B, back to A to B. Then we look at the circular motion. That's the motion of the heart about its axis of rotation. Then we have the rotational motion. You see the motion of the fan and the blade of the fan. That's good. Now let's look at this. This is random motion. Let's assume an object is to move from A, B to C to D. You discover that it's zigzag. The movement of the object from A to Z is not defined. It does not have a proper orientation or direction. So any particles that move like this, A, B, C, D, like that, in a zigzag manner, it is regarded as a random motion. Now, then we have another motion we call relative motion. But I want students to pay attention to this. Relative motion is not a type of motions like the 4 types of motions we mentioned earlier. But before I progress, remember that motion of body could be combination of 2 of these types of motion, 2 of any 4 types of motion we have mentioned above. The motion of the body could be both rotational and translational. For instance, the wheel of the vehicle. The wheel of the vehicle is rotating about the rim, which is the axis, and at the same time, there is a movement of the wheel from, let's say, for instance, from Lagos to Ibadan. So it is the wheel is performing 2 motions at the same time, rotational and translational. But let's move to relative motion. Relative motion is the motion of a body with respect to another body. You will have experienced relative motion. For instance, when you are traveling and you are inside the car, you sat down in the vehicle and then you are traveling, let's say, from Lagos to Abuja, and you discover that when you look outside through the screen, you look outside, you discover that it looks like buildings are moving. It looks like trees are moving. But it does not mean that the trees are moving. In actual sense, the trees are not moving. But the movement of the trees or the houses is what we call relative motion. The motion takes place because you are moving. So relative motion is a motion of a body with respect to another body. For instance, let's consider 2 vehicles P and Q. If 2 vehicles P and Q are moving on a straight line at the same velocity, 2 vehicles moving on a straight line at the same velocity, to the passenger that is sitting behind or to the vehicle behind, which is an observer, it appears as the vehicle ahead is stationary because the distance between them and the speed between them is the same. So because the gap is maintained, it will look as if those at the front are not moving. For instance, let me cite it better. Let's say someone in a vehicle, someone is sitting at the front and someone is sitting at the back. The 2 of you are traveling. Though he's sitting at the front row, you are sitting at the back, but as you are moving, he's ahead of you. There is a distance between the 2 of you, but because the 2 of you are moving at the same velocity, it will appear as if the person at the front and you that are sitting at the back, you are stationary. It will be as if you are not moving at all. That is what we are talking about. Now, let's look at B. Another condition If P travels at 100 km and Q at 90 km per hour, then to the passenger, the speed of P relative to Q is 10 km per hour. We can assume that Q is at rest while P travels. Let's look at this diagram for better illustration. Look at these two vehicles. The vehicle at the front is traveling at 100 km per hour. But the vehicle at the back is traveling at 90 km per hour. You look at the difference between their movement is 10 km per hour. So to the passenger inside the blue car, the passenger inside the blue car will be seeing the passenger inside the red car. So I'm looking in this diagram that the kilometer is 10 km per hour. So the difference, the velocity of the one behind to the one above is 10 km per hour. Let's look at another one now. If P and Q now travels in opposite direction, then the velocity of P relative to Q is 190, because if one is moving 100 and the other is moving 90, by the time they crosses each other, then you discover that the velocity increases and the range increases in that order. And that is why the velocity keeps increasing at 190, that is 100 kilometer plus 90 kilometer per hour for the two vehicles. Now we have other consequences of relative motion. Aside the movement of two vehicles, we have what we call the Doppler effect in sound and even in light due to relative motion between the observer and the source. This thing occurs when you see a siren blowing from a far distance. You'll be hearing the sound of the siren very faint because the distance is far. But as the vehicle moves closer, you discover that the sound of the siren becomes broader and louder and louder. And as the vehicle passes, you discover that it becomes fainter and fainter as the vehicle passes. That experience is what we call a Doppler effect. It occurs in sounds, it also occurs in light. Now let's look at the concept associated with motion on a straight line. Now when talking about motion on a straight line, there are things you must understand. You must understand what position is, what distance and displacement is, bearing, then scalar and vector. So let's quickly go through to that. Now, position. What is position? The position simply means the location of a point. In other words, the location of a point with reference to another point is what we call position. If I say, what position are you? If I say first, then first out of what? So which means if I have two students in the class, if I say I'm first, then my position is relative to the numbers of people in that class. So 1 out of 2. So I'm first, while the other person is going to be the second. If we are 3, if I'm first, then the other people will be second and third. So what we are saying is that position is talking about the location of a point with reference to another point. Now, the position of any point in physics is determined and specified by two quantities that we regard as coordinates. The position of any point is determined by determined and specified by two quantities known as coordinates. If we say the coordinates of a point P is 2, 3, the 2 represent the x-axis, the 3 represents the y-axis. So we mean that the distance of P from the origin 0 in x direction is 2 and 3 in y direction. Let's look at this chart. You see in this chart, you discover that the point P in this diagram, if you look at this axis, we have the vertical axis, we have the horizontal axis. So let's look at the origin. If this object, the blue object from object O, from origin O, have to move to point P, then discover that it's going to move by counting 2 steps in x-axis and 3 steps in y-axis. That's why we have 2, 3. So the positions of an object in physics, we use coordinates to determine the location or position of an object. Now let's look into another parameters of motion, which is distance and displacement. What is distance? Distance is the measure of separation between 2 points. It is measured in meter and it's often denoted with s. It is the separation between 2 points. If I measure 2 points, if I place the point A, 1 point, and I put another object at another point, the separation between the 2 points is what's called distance. Then what is displacement? Displacement is now distance traveled in a specified direction. The distance traveled in a specified direction is also measured in meter and is denoted with x. But let's quickly look at what is now the difference between the distance and displacement. Now, that's why you need to understand that concept. Distance and displacement are not the same. So we want to look at what are the difference between the two. Look at this first diagram here. You see a line drawn from point A to another point. Okay, Then you see another dotted line along the line. Now the dotted line indicates distance. For instance, if a boy wants to travel from Lagos to Abuja, you first go to certain ports, certain park, then drive to certain park, then the car will always have to pass through certain routes before it gets to Abuja from Lagos. But when we're talking about a plane, if a plane wants to move now from Lagos to Abuja, a plane does not need to pass through a particular route. It has to just lift and then use a cardinal point or use a compass and then locate the point it's going and then fly in that straight direction. So that is what the differences between distance and displacement is. Distance is just the measure of separation between 2 points, while displacement is the distance traveled in the specified direction. So I've seen in this second diagram, you see like the boy want to travel from home to the stadium, and he has to pass 4 kilometers one direction, and then he has to pass 3 kilometers another direction before he gets to the stadium. But if you want to use displacement, the displacement is just distance traveled directly from home in that straight line to the stadium. And that is why if I want to calculate distance covered by this boy in this chart, the distance covered is going to be 7 kilometers, while its displacement is going to be 5 kilometers using the Pythagoras theorem, which says hypotenuse square equals opposite square plus adjacent square. Now let's look at this chart and look at the differences between let's look at the differences between these 2 points. Let's look at it. So the difference between distance and displacement. Distance is the length of the path traveled by a body while moving from an initial position to the final position, while displacement is the shortest distance between the initial position and the final position of the body. That's number one. Number two, distance is a scalar quantity, while displacement is a vector quantity. In previous classes, I've explained what scalar quantity is. That I said scalar quantity has magnitude but no direction, while vector quantity has both magnitude and direction. Number three, distance measured is always positive, while displacement can either be positive, negative, depending on the reference point. Alright, like in that graph, we can say negative, we can say positive. Now let's look at the total distance traveled is equal to the algebraic sum of all the distance traveled in different directions. Why? The net displacement is the vector sum of all individual displacements in different directions. Number 5, there is always a distance covered whenever there is a motion, but displacement will be 0 if the body comes back to the initial position. That is, if I move a body from a point A and I move it round, and I go back and return the body back to position point A, then the displacement of that object is 0. Though the object moves, but it has not been displaced because it has returned back to its original position. But if it is distance, as it moves, we calculate the distance along the line. Then, distance is measured in meter, and displacement is also measured in meter. Now, let's look at another parameters, bearing. The 4 cardinal directions are the north, south, east, and west. So the bearing of a point is the angle the point makes with the northern direction. Look at this chart. You have the simple compass rules here. Where we set the cardinal point. You have the north, east, south, west. Then we have another one which is the northeast, southeast, southwest, and northwest. So you can just pause the video and study the chart. Alright, let's move. We have the scalar and vector. As I've always said, the scalar quantity has magnitude but no direction, while vector quantity has both magnitude and direction. For instance, distance has no specified direction. It is just measure of separation between 2 points. But displacement has specified direction. It is distance traveled in a specified direction. Now let's look at the parameters of uniformly accelerated motion. The parameters required to describe motion in the straight lines, they are displacement, distance, speed, velocity, acceleration, and time. Alright, now in this class we have explained displacement, we have explained distance, and we have explained time. So we just look into speed, velocity, and acceleration. As I said here, so let's move now. Speed and velocity. If you look at it, speed is just defined as the rate of change of distance. In other words, you can say speed is distance over time. Look at here, v is d over t. But let's look at velocity. Velocity is defined as the rate of change of displacement over time. So see here, V is S over T. But sometimes the formula for speed can also be used as V equals to S over T. So it's very important, depending on the context, you need to identify the parameters correctly. So if you're using distance as S, you have to take note so that when you see in the question your formula and your parameters must be the same, must look alike. All right, let's look at acceleration equations. Look at it. What is acceleration? Acceleration simply means rate of change of velocity increase with time. I repeat, acceleration is defined as the rate of change of velocity increase with time. While deceleration is the rate of change of velocity decrease with time. You have to get that right. So the formula is acceleration is going to be change in velocity over change in time. And as you see in this chart now, you discover that the car starts from initial position, it has moved to the final position, and in the process, it has increased its accelerations and distance has been covered. So we have some parameters like initial velocity, initial time, final velocity, the final time, and then we can have a formula as we have seen in this chart. So you have to master that formula. The acceleration is change in V over change in T. Now, let's look at the concept of uniformly accelerated motion. Uniformly accelerated motion is simply the change in position of a body with respect to time on a straight line with constant acceleration and zero difference. Some parameters are associated with uniformly accelerated motion. When we say uniformly accelerated motion, we are talking about motion of a body on a straight line. And as the body moves on a straight line, there are some parameters that are associated with that. And those parameters are: number one, we have what we call initial velocity U, we have final velocity V, we have acceleration A, we have distance D or S, and then we have the time T. And their unit of measurement has already been in place there. And remember, in the first topic, we talked about the unit and measurement, so you have to put it there. All right, let's move. It is important to note these three things. When a body accelerates from rest, what it implies is that the initial velocity of the body is zero. Please, this is the concept you need to master. When they give you some questions in calculation in physics, they will not give you these parameters. They will not say initial velocity of an object is 0 meter per second. They will only say an object starts from rest. So whenever an object accelerates from rest, it implies that the initial velocity U of that body is 0 meter per second. Number two, when a body comes to rest or brought to halt, H-A-L-T, it implies that the final velocity V of the body is 0 meter per second. And number three, when a body moves with uniform velocity, it implies that acceleration of the body is 0 meter per second squared. That is, when the velocity is uniform, it means the body is neither accelerating nor decelerating, and which means acceleration at that point is 0. Good. Let's look at the equation of motion. These are 5 equations of motion that you must master. So before next class, I want you to review and go back through what we have done today and master it and prepare yourself against next class. So next class, I will be using and applying this equation of motion. There are 4 equations of motion. Number one, V equals U plus AT, where V is velocity, final velocity, U is initial velocity, A is acceleration, and T, time. That A is acceleration of the body. Then number 2, S equals to UT plus half AT squared. S is the distance, U is initial velocity, T is time, as we have it in that formula. Then number 3, V squared equals to U squared plus 2AS. And number 4, S equals to half into bracket U plus V close bracket T. Please, before next class, master these 4 equations of motion, because by next class, I will try and see how we can interact with this equation to solve some problems around. So that's that about that. So see you next class when we shall begin to apply this equation of uniformly accelerated body. Please go through these lectures, just watch again. Make sure you like this video, subscribe to this channel, and turn on the notification bell if you have not done so. All right, see you next class. Thanks, and God bless you.